Greetings, I'm Bart Massey. Welcome once again to Intro to Programming. Today I want to talk about a little problem in string manipulation that's often an early problem people work on when they're doing learning how to work with strings when learning to program, and that's the problem of palindrome checking. So what's a palindrome and what does that look like? So an example of a palindrome is radar. If you look at the word radar, it reads the same front to back. R-A-D-A-R going this way, R-A-D-A-R going this way. Now that's a pretty small palindrome. Here's some bigger palindromes. Here's Madam, I'm Adam, which again, if you ignore the spaces and the apostrophe and stuff, maybe even, you ignore the case in that case. So if you ignore all this extraneous stuff, sure enough, M-A-D-A-M, I-M-A-D-A-M, Napoleon's thing, that's a palindrome. Able was I ere I saw Alba. One of the famous ones, a man, a plan, a canal, Panama. That's a man, a plan, a canal, Panama. So you get the idea that that's what a palindrome is. And what we might ask ourselves is, well, yeah, but that checking I was doing was pretty tedious and it'd be easy to make a mistake. If somebody hands me something and says, is this a palindrome? This is a palindrome. I'd like to be able to check their work and say quickly, and without making any mistakes, yeah, that's a palindrome, or no, it's not actually a palindrome. And to do that, I might want to write a computer program. So what we're going to do today is write a computer program for palindrome checking. And I've actually got this one written out. I'm not going to try to write it on the fly, but I am going to walk through it carefully and show you what we were doing when we built it and how it goes. We start as usual with a description of what the program does, check whether the given string is a palindrome, a description of who wrote it and when. And then we're going to write this function. Remember, one of the things I said is you need to ignore all the punctuation and make everything, you consider a capital A and a lowercase a to match. We want to be all case insensitive. And so we're going to write a function that takes a string, strips all the non-alphabetic characters out of it, and returns the rest, whatever's left over, but converted to lowercase. So any uppercase letters are translated to lowercase. And that way we can take our proposed palindrome and worry about just the letters without all that extraneous baggage. So how does this work? Well, we're going to start with an empty string, and we're going to make longer and longer strings by adding the characters, when appropriate, of the thing we were passed in. So we get this result string that's going to be nothing to begin with, and we're going to look at each character in the string we were passed in. Remember, the string here is just a variable that contains supposedly some string value. What happens if I pass a non-string to the string variable? Well, this program will probably fail in some terrible way, so don't do that. So for each character in the string, and remember in Python characters are just one character strings themselves, if it's not alphabetic, c.isAlpha, it turns out, returns true if the string is a letter of an alphabet, and it returns false otherwise. Let's look at that. That is true. 0.isAlpha is false. If I go, that's a capital delta. That is an alphabetic character. Here's a lowercase delta. That is also considered an alphabetic character. So all these things are alphabetic characters, and that's all we're testing for here, is that the given character, the character we're looking at as we go through the string, if it is alphabetic, then we put it on the end of this result. So this is a pretty classic programming pattern where you process a thing and then put it onto the end, process a character of a string and add it onto the end of a result like this. This result is sort of accumulated. It's sort of built up from left to right. So when we look at the first character of the string, if it's alphabetic, then we get the result is now the empty string plus the first character. So that'll give us a string that's one character long and has the first character. And if we keep going like that, we'll look at the second character, do the same thing, and so forth. And so when we're done with this loop, when we get to this point, all the characters in result should be alphabetic. And then I also wanted to convert it to lowercase. So at the end, I'm going to use the lower method of strings to convert it all to lowercase. So lower, it turns out, takes a string that might have upper and lowercase characters in it. If I lowercase that, all the uppercase characters are converted to lowercase. And so at the end, we make sure that everything's converted to lowercase. So that's a fairly fancy function. I'm a little afraid that it's not going to be right. So I'm going to write some tests for that function to make sure it's okay. And to do that, I'm going to introduce a new concept today, the assert statement. The assert statement checks whether its argument is true or false. If it's true, it doesn't do anything. If it's false, it crashes the program. So if I assert true, no big deal. If I assert 1 equals 1, well, absolutely. If I assert 1 equals 2, which is false, then I get an error. And this is a pretty classic way to check that things are okay. And I'm just going to use it here to check that if I canonize the empty string, I should get the empty string back. If I canonize a string containing a capital X, I should get a string containing the lowercase x back. And if I can canonize this blob of stuff, which includes a new line and some spaces and digits and dots and some uppercase characters, the only alphabet characters in there are X, Y, and Z, and so I should get those out all converted to lowercase. It's a really good idea to write this. This is called a unit test. These are called unit tests. It's a really good idea to write some unit tests when you're worried about your function to make sure that it works right. I can call this test canonized now, and it will check all these cases and make sure my thing works right. So now I have a function that sort of cleans up the string. Now I want to actually check to see if it's a palindrome. So how am I going to do that? Well, I'm going to look at the first and last character and see if they match. And then I'm going to go in one more character and see if those characters match. And I'm going to go in one more character and see if those characters match. And if at any point they don't match, then the string's not a palindrome. I keep going like that. And at some point I'll meet or cross over in the middle. That's fine, we'll just keep going, and now we'll be checking the other way. And when I've checked all the characters twice, because it's the easiest way to do it, then if I haven't seen any mismatches, then I will decide the string's a palindrome, and otherwise I won't. So let's look at this again. If I look at Madam, I'm Adam, I'll check to make sure the M's match, then check to make sure these A's match, then check to make sure these D's match, and then check to make sure these A's match, the M's. I check to make sure the I matches itself, which it does, because characters always match themselves. And then I keep going like that. I check this M against this M, and so forth. And eventually, when I've got out to the end, I will have checked everything and it passes all that, so it's a palindrome. If I have some mistake here, I match these two, great. I match these two, not so great. A is not the same as E, so this is not a palindrome. So that's the logic that's in here. I find out how long the string is. I don't think this actually is a bug. I gotta be careful here. I don't think that there's a comment that says here's a bug, see it, but there's no actual bug. That's always a problem. I originally wrote this like this. The idea here is that if I know the length of the string, end string here in this case, what I'm going to do is I'm going to say, well, start with the first character in the string, character 0, and match it against the last character in the string, the character at the end minus 0. Well, the problem here is that the end isn't, right? If the string is 3 characters long, then the first character is at 0, the second character is at 2, but 3 minus 0 isn't 2. I really need one more here, so I'm going to go like that and strip off this bug that I should have seen from the beginning. And it's really easy to make bugs when doing this kind of stuff, and that's why it's worth testing these things and checking them carefully. But the idea here is I'll check the first character against the last, I'll check the second character against the second to last, and so forth, all the way to the end of the string. I'll check the last character against the first. Actually, is this a bug? Gotta be really careful here. So when I get to end string minus 1, yeah, no, that's all right. So this will check the last string against string 0. And if any of these mismatch, if this not equals ever hits, I'm going to return false. But and that'll be the end. I'll get out of this function. If I get to the end and I haven't found any mismatches, well, then it must be a palindrome. It must be okay. So that's nice. And again, I'm going to write some tests because this kind of code is easy to get wrong. Is the empty string a palindrome? Well, it is, right? Every character, sort of, you can reverse it and it still is the same as the original. I mean, that's kind of boring, but it's true. Is any single character a palindrome, alphabetic character a palindrome, or any character a palindrome? Yeah, they are. What about something like this? Yeah, that's a palindrome. This should not be a palindrome, so I'm going to check that it isn't. It's important to include negative tests as well as positive ones. That is, you shouldn't just check that it returns true when it's supposed to be true. You need to make sure it returns false when it's supposed to be false. This is a palindrome. This is a palindrome. This is not a palindrome because the Y and the Z don't match. Yeah, so I've got some tests here to make sure this is going to be okay. And then the main program, I'm going to start by just running the tests. This isn't something you'd normally do in real production code. You'd arrange somehow to make sure that they were only run when you wanted to test the program. But for a simple thing like this, it's fine to just include some tests and make sure they run. So if any of these tests fail, the program will crash, calling test canonize or calling test is palindrome, and we'll be out of here. And after that, we'll ask the user to give a string to test if it's a palindrome. We'll make sure we canonize that string so that it's in the right format to be checked by is palindrome. And then the truth value will be, well, is it a palindrome? So this will either be true if it's a palindrome or false if it's not. And we will print that answer. And that's the whole story of this program. I'm going to step through the execution of this program the first time just so that you can see what's going on here. So it starts by reading the definition of canonize, reading the definition of test canonize, reading the definition of is palindrome, reading the definition of test is palindrome. And now we're going to actually start doing things. I'm going to step into this function for just a second. And it runs the first test, says, yep, that's fine. Runs the second test, yep, that's fine. Again, the program would have stopped with an error if the test had failed. Is this okay? Yeah, it's fine. And then we get out of that function call and we're back up at the top and we start running the second test. So we step into that and make sure that all the tests actually pass. Looks good. Yay, the negative tests pass too. And so now, we haven't proven that the program's right, but it probably is okay. Those functions are probably fine. Now let's actually get a thing to test. And when I input that, then the string pal over here in the variable area, which always gets squunched up, I really need to fix that bug, is sure enough, candidate is set to the thing we typed in. And as I step over this line, it will actually check, is this thing a palindrome? And you'll notice that it says true. Palindrome is true. So yep, sure enough, that's a palindrome. And then we'll just continue to print out the message. Yep, good enough, good enough. Let's run that again with a non-palindrome. Suez is not a palindrome. Sure enough, it's not. And the execution is exactly the same as what I showed before. So that's how we work with strings. We use these string functions and string expressions and string tests to sort of figure out what's going on with the string. We're careful because it's really easy to screw up with this string indexing. When we compare characters and strings, we do it in such a way that we make sure we compare the right thing with the right thing. And, just breaking things down into functions that you can test separately and that have sort of separable work is a really, really good idea. So there it is, the is palindrome test, a classic test. Later in the quarter, we'll ask you to write some tests like this of your own, but for starters, I think this is one that we can give you so that you can get an idea of sort of how we work with strings in realistic programs. Hey, I know things are super tough out there for some of you right now. It's definitely difficult times. Please stay safe and well, and I enjoyed talking with you and hope to talk to you again soon. Take care.